based on the existing works, we have coming out with these criteria.
Maybe just to expand on that, was that criteria related to the table that you displayed on another slide that showed?
This one?
No, it was the larger table that talked about whether it had the high or low, the number.
This one?
No, I can't remember which slide it was. It was a very, very large table.
This one?
No, keep going. Yeah, that might have been the one, yeah. Was that listing how it was validated, looking to make sure that it satisfies all those feature sets?
Yes, this one criteria has been formulated based on the related works.
Yep.
Also based on the existing SDN datasets. As can be seen, some datasets having less number of features, which is not efficient, not enough for the researchers to understand more about the network, the attacks patterns. Datasets having incompleted columns. Some datasets, they are focusing just on standard or conventional DDoS attacks. Some datasets, they have less number of instances, which is not sufficient for deep learning. All these limitations. So we came up with these criteria. Is it clear?
Yes, yes, thank you very much.
Thank you.
Other questions? Oh, yes, sir.
Thank you for a very nice presentation. Perhaps I missed something regarding the high and low data rate. My first question is, what is the high data rate and what is the low data rate? I mean, how you defined it in your research. And the second question is, what is the impact of high and low data rates?
In high rate data, the DDoS attack, the attackers send a massive or spoofed traffic against the victim node. Okay? But in low rate, the attackers send a slow malicious traffic against the victim, against the victim node that affects the SDN controller by the time, not immediately. The impact of high rate is, we can say it immediate, but at low rate it takes some time. That's the major difference between them.
Yes, thank you for that response.
Thank you.
Is there any other questions either on Zoom or within the room?
Okay.
Just see, is there any questions in Zoom as well?
Hello. I have one question about the size of the data set you proposed. Actually, in this table, I think there should be one column related to the size, because size makes a big difference in the results also.
The size here, can see axis.
Any other questions? Excellent. I think that is all for the questions. Thank you again for your presentation, Mr. Bahashwan. And we'll move on to the third presentation. Third presentation is from Mithiran Parathban, sorry about the name butchering here, presenting on MALBED, enhancing peer-to-peer botnet detection with specialized testbed. So I'll hand it over for your presentation, sir.
Good day everyone, my name is Mithiran Parathban, and today I'll be presenting a title called MALBED, enhancing P2P botnet detection with a specialized testbed. And I'm doing my master's in National Advanced IPv6 Center in University of Science Malaysia. So this will be the agenda for today, where I'll be giving a brief introduction to the topic, and I'll be moving on to botnets, the different type of botnets and how they interact with each other, followed by problem statement, monitoring mechanisms, and finally I'll be concluding the presentation. So as we all know, the cyber attacks trend globally is going up, and this is due to many reasons, and one core reason is malware, where in 22nd July 2024, a malware called Soft Golish exploited a research center where they are used as devices to conduct research projects. And in the United States, officials found 19 million infected computers that enable identity theft and also child exploitation. And 19 million devices were found globally, not just in the United States. And also in the start of this year, researchers uncovered the major surge in global botnet activities. Botnets have caused millions of damages or even billions of damages, and in 2024, as of now, $30 billion $30 billion damages are caused by botnets alone. And I would like to highlight this graph here where it shows Mirai botnets targeted Asian hosting providers with 2 TB per second DDoS attack. And I say variants of Mirai botnets because Mirai botnet source code has been made public and there are many variants of Mirai botnets. So I've been talking a lot about botnets in the past 2 slides. So what is a botnet? It's a network of comprised devices controlled remotely by an attacker. Botnets are used to perform malicious activities like DDoS attacks, sending spam, or even spreading malwares. Botnets pose a widespread threat because they consist of millions of devices across the globe. There are 3 different types of botnet. The first one is a centralized botnet, where it's controlled through a central C2 server where all bots receive instructions from the bot master. And second one is the decentralized version of it, where it's similar to a centralized architecture, but it uses multiple redundant C2 servers. C2 meaning command and control servers. And finally, the most interesting part is the peer-to-peer botnets, where each bot acts as a client and a server communicating directly with each other. So I would like to highlight 2 types of botnets. The first one is centralized, and second one is peer-to-peer. And as I mentioned, centralized botnets are botnets that uses a centralized C2 server, and the bots regularly poll to the C2 servers for updates from the bot master and apply them immediately. This architecture is easy to deploy and has low communication latencies, but it has a major disadvantage where it has a single point of failure and the entire botnet becomes inoperative if the C2 server is removed, and defenders can easily track and enumerate all infected machines. The second one is the peer-to-peer architecture, where it eliminates the vulnerabilities associated with centralized architecture by avoiding the single point of failure seen in the centralized system. And the network can continue to operate even if the individual bots are taken down, as commands can be injected to any bots, which allows multiple entries for the bot master to inject their commands, making it harder to trace the bot master. Given the growing complexity of peer-to-peer botnets, traditional methods are insufficient for effective analysis. Primarily, there are 2 types of monitoring approaches for peer-to-peer botnets. The first one is in the wild, the second one is test-bed. So the main differences between the in the wild analysis and also test-bed analysis, where in the wild analysis, the tracking activities of known botnets are currently active in their natural habitat, meaning the analysis is done using real-life botnets that are currently present globally. But it comes to a risk where operators, if they detect that they are being monitored, they potentially trigger attacks to show retaliation. Whereas in testbed analysis, emulation experiments are conducted using machines and infrastructures within a laboratory. It empowers comprehensive investigation across diverse parameters and gives unwilling insight. So the problem statement for this topic is ideally we want a controlled and secure environment to analyze the behaviors and vulnerabilities of peer-to-peer botnets. However, the decentralized nature of peer-to-peer botnets and the need to prevent any risk to actual network infrastructure complicate the study of peer-to-peer botnets. As a result, researchers face challenges in developing effective mitigation strategies, potentially leading to incomplete understanding and insufficient defenses against peer-to-peer botnets. So I've mentioned that monitoring mechanism is a crucial part in analyzing a peer-to-peer botnet, and in terms of monitoring mechanism in peer-to-peer botnets, it involves analyzing network traffic to detect command dissemination and cataloging infected devices to understand the botnet scale and structure. To enhance these monitoring efforts, a dedicated testbed serves as a primary environment, providing a controlled and secure platform to safely deploy, study, and refine monitoring mechanisms for deeper insight into the peer-to-peer botnet architecture. So as I mentioned in the previous slides, testbed analysis is crucial for peer-to-peer botnets, but what are the features that is needed within testbed to have an effective analysis? We have done our research and we have seen to related works, and we have come up with 5 features that are crucial to have in any testbeds for effective peer-to-peer botnet analysis. The first one is security, followed by fidelity, scalability, automation, and finally reproducibility. So let us look into each of these features for better understanding. And services like DNS and HTTP and other crucial services should be replicated within the testbed for authentic botnet behaviors. Third one is scalability, and as we all know, the testbed should be able to support large-scale replication of nodes and networks, and the testbed should be designed to easily scale up or scale down depending on the number of nodes within the topology. and depends on the peer-to-peer botnet's requirements as well. Automated deployment and configuration of nodes to reduce manual intervention, where structured configuration files automate and manage the test bed infrastructure. And also the automation should be able to modify the malware execution and also test during the analysis for a better understanding of peer-to-peer botnet. And finally is reproducibility, where it requires a thorough documentation of network topology and configuration to ensure experiments can be replicated. The testbed should use version controls for configuration and scripts, ensuring that changes can be tracked and experiments can be repeated under consistent conditions. So I'd like to conclude today's presentation by highlighting what we have covered so far. The first one is we have highlighted the problem caused by malware, especially botnets. We have also reviewed the different types of botnets and what botnets are. And we have seen the different types of peer-to-peer botnet analysis. And finally, we have reviewed the features needed for a test bed for a peer-to-peer botnet analysis. And I also like to mention that this is a very high-level presentation, and currently we have a work in progress for the deploying the test bed as well.
Excellent. Thank you very much for that presentation. Do we have any questions in the room or remote over Zoom for this presenter? No, I think you displayed everything very clearly in your presentation, so we don't have any questions at this time. Might just leave your slide up just for another second or two if anyone wants your email address or contact details, but thank you very much for that presentation. Excellent. Well, that concludes the 3 presentations for the Security Working Group for APAN 58. Thank you very much to all of our presenters and to the co-chairs for their work. The next conference will be APAN 59, which is going to be held in Tokyo. So we'll do a call for papers out through NRENs and various organizations to see if there's any interests from various organizations for next year. But please keep an eye out for that email when it comes out. We're finishing just a few minutes early before break time, but thank you very much for everyone who's attended, both remotely over Zoom as well as for those that are in the room for this session. Thank you very much, and we will see you on email before the next APAN meeting. Thank you very much, everyone.